said Brendan.
It started, my guy.
Oh my God, this is started. Hey.
Go. Say what?
Oh my God.
Okay, this is lesson 3-1. So we're starting our next unit called transformations. Again, today is a lot of Algebra 1 skills and not a ton of geometry skills. So, could be good, could be not so good for us. The way these notes are set up, these 3 examples are done for you, so you can refer back to them. But we'll notice some, hopefully, some things that you've seen before. Do you guys remember these T-charts from Algebra 1 at all?
Yes.
You're given an input value like 0, 1, 2, 3, and you're given some kind of function to plug into to get my output. That is all that we're essentially doing today, so hopefully it should be pretty easy. So we are given a function here, f of x equals x squared minus 3, and they gave us a value of x. Would that be my input or my output? What did they give me here? They gave me input, so can you please write that? They gave me input. Does anyone know another way of writing f of x? What's another way of representing that? F of x is the same as what?
1.
F of x is the same as our what value? If they gave me my x, I'm looking for my y. Very good. So f of x is just another way to write y. So here they are giving me the input. So I think you have room maybe up above or maybe off to the side. If they give you input, what do we do with input? What do we do with input? We plug it in. Very good. So input means we are going to plug in values. So wherever it makes sense to write this, I think you have room off to the side or up above. But when they give you input or my x value, we are going to plug that value in. Right, so here they have f of -2. That is just telling me we're plugging in that value of -2. So we have replaced or substituted in -2 for x. Again, these are just examples done for you. Now we're going to try our own down here. So they told me I have a function and they gave me my input value of what? What did they give me as my input? We're underneath at our own example number 1.
4.
Yes?
4.
4. So we are going to do f of 4, which means wherever I see an x, we're now going to be plugging in a 4.
So we put 2, 4? 2 like.
You are writing exactly what I'm writing. If you have a serious question, just wait until the top of the video. Okay, f of 4. So wherever we see x, we are now plugging in 4 with parentheses. I could put that last 4 in parentheses, but I don't have to there. So we have replaced every x value with the value of 4. So this is just PEMDAS, right? So we're going to start with parentheses if we have them. Can I do anything with that parentheses? It's just a 4, right? So we move to what? What does the E stand for?
Exponents.
Exponents, very good. So we're going to do 4 squared. So 4 times 4 is 16. So I'm going to bring that down in parentheses. I'm going to bring down everything else. So I'm just solving for my output here. They gave me input. I am solving for output. Next thing I want to do is multiply. So 2 times 16, 32. And I'm going to add 4. So my output would be 36. In geometry, we do a lot more with the coordinate plane. So we are actually making an xy coordinate point. So my final answer is going to be my x value that they gave me. So what was that? 4, comma, my y value, 36. So there's my new coordinate point. So we're going to actually be graphing these next week and seeing how the movement happens with these input-outputs. But we're just making sure we're good with the algebra today. Questions with that? I would like you to try the next one, and let's try both of these. I'm going to pause the video and try both of those on your own. All right, so check your answer for number 2, and then let's do number 3 together. So we are plugging in a positive 5 here. So we have a lovely fraction, which are not too bad, especially in this case with really simple numbers. So does anyone remember what or how we can make any whole number a fraction? We put it over what? We put it over 1. Okay, and then that helps me to multiply these fractions together. Who remembers how to multiply fractions? Straight across, very good. So we are going to go straight across. So we have negative 2 times 5.
Negative 10.
Negative 10 is our numerator, and our denominator would be what? Positive 5. We have, this is just a division problem. Any fraction is just division. So negative 10 divided by 5 gives me
Negative.
negative 2 is my output or my y value. So my point would be 5, comma, negative 2. Not too bad, right? They give me the input. I'm plugging it in to find output. Let's move on to our next set of examples. What did they give us here? They didn't give us the x anymore. They gave us the what? They gave us the y value or my output. So off to the side, underneath it, wherever makes sense to you, here's where they give us the output and we are solving for input. So you're going to set equal to a value or to my output. We're going to set it equal. So we're no longer plugging in a value, we're setting it equal to the value. Again, the first 3 examples are just done for us. Just done for us so that you can refer to it. So we have negative 3. We're now setting our equation or our function equal to that negative 3 and working backwards to solve for x or solve for our input. So let's go ahead and try one of these. I'm going to go ahead and take my value that they gave me. So what did they give me as f of x? Good. Negative 29 is now going to take the place of f of x. And I'm going to set it equal to whatever function they gave me, which in this case is 8x minus 5. Are we okay with that step? So take the value that they gave me as output and set it equal to the function. And now it's just a simple problem, so we're going to solve for x here. What's my first move?
Minus 5.
We have a negative
We'll
5,
add
we
5.
want to add 5. Good, we want to cancel those out. So I'm going to cancel those out. I'm left with 8x. Okay, these are different signs, right? So we're going to subtract and keep it negative. Good. And I'm going to divide by 8, so x equals negative 3. And now I can finish with my coordinate point. So my x value is negative 3. My y value is what? Negative 29. Which they gave that to us. Okay, so these kind of are working backwards to solve for my input. Okay, I'm not going to pause here. We're going to do this one together, but if you can go ahead and set this one up on your own, please. So take a second and set this one up. So they give you the y value. I just want you to do the setup, and we're going to work through it together. So what would I set this equation equal to? Awesome. Just do the setup, please. Oh, set up this one. Okay, they give you the y value. So what's my y value or what's my output value? Good. So I take whatever they give me, the output value, and I set it equal to the equation. So we're really just replacing f of x with 13. That's just like taking the place.
Oh.
Okay, so that's just in our setup. If I'm just trying to get x by itself here, what would my first move be?
Plus 14.
Add 14, very good.
You would cross out the 14.
Yeah, I'm going to bring down my x. What do I say?
27.
X, what is that?
Cubed.
Cubed, very good.
So 27.
Okay, in order to get rid of, just like we get rid of a square, we do what to get rid of a square? We square root something. If we have a cube, we do the same thing, except it's called cube rooting. So you're looking for a number times itself 3 times. That would give me 27. Not 9.
3.
3, right? Because I have 3 times 3 times 3. That's 9 times 3, which gives me 27. So the actual number there, or the actual answer is 3. Okay, so if I were writing this as a coordinate point, it would be 3, 13. 3, 13. Okay, and let's do the last one together as well since it's a fraction, but I'm going to pause here and let you guys set that one up and ask any questions. Okay, so after my setup here, I'm solving for x. So if I have 3 on the denominator, the only way I can cancel it out is to multiply by the same number on either side. Okay, that cancels out my 3's here because 3 over 3 is really just 1. Those cancel out. I'm left with x. And what is 3 times negative 15? Negative 45. Just like minutes on a clock, right? 15, 30, 45, 60. It's a good way to remember this. So that's my x value. So let's go ahead and write out my coordinate point. Negative 45, comma what?
Negative 15.
Negative 15. Questions with just the input output. Now we're going to add in the geometry piece. You ready? This is at the bottom of your page. We're going to make a few notes there. So the only thing that changes with geometry is, of course, the vocab. We always have to have new words for everything. Like congruent is just another word for what? Equal. So we have to have some new words here. So we'll get into transformations next week, but it's actually on a graph taking an original point and moving it somewhere else. So this is showing us basically a function or a rule that is going to move an original point. So we see my input here is just a coordinate point x, y. We call that now the pre-image. So think original. Okay, pre means like what? Do we know what pre means? Before, right? So it's before we have plugged in the value or before we have moved it. So the original is called the pre-image. Can we say pre-image? Pre-image. Okay, and then we have this function over here that is telling me how to change my x and y value. So it's telling me to do what to all my x's? What is it telling me to do?
Add 3.
Add 3. So I would say I would add 3 to the x if you want to underline that part. It's just explaining it in words. And it's telling me to do what to my y value? Subtract 6 from my y value. So this would actually shift it on a graph, which we'll see next week. Today we're just going to focus on the math. So it becomes now the image. So we drop the pre. So we're either saying pre-image as my input and image as my output. So we're going to kind of ignore input, output, and use pre-image and image now. The way that we write that, we know this is a point, right? Point A would just be any coordinate point, x comma y. The way we note an image or after the transformation has happened is a little prime symbol. So in parentheses, if you can write A prime. So it's like a little apostrophe next to the A. That tells you that it is the image or my output. So you're going to have to pay attention in our next ones to see which one they give us. But please write in parentheses A prime. So that is how you would say that. A prime. A prime. All right, let's go ahead and try one of these. So again, the only thing that has changed here, is the words. So it tells me I have a coordinate rule. They're always written in this format with a x, y, and an arrow. This is just the same thing as a function. So it's adding 3 and subtracting 6 for my y's. So we're going to do this in a second, but just notice they take my original pre-image. How do I know this is a pre-image and not an image? There's no what? Would anyone remember what the full name is? You just wrote it. There's no what symbol? Prime symbol, right? If there's not a prime symbol, this is my input. So they plugged in my values into the function and got my new image point. So that's the only difference here is the words that have changed. So first thing I'm going to do, I have a point A, 3, 2. Is that a pre-image or an image? Pre-image. How do I know? There's no prime symbol. Good. So we're going to write that down. So this is my original pre-image point. Okay, it gave me a function. It says I have 3x minus 1. I'm just going to draw an arrow and write out my function for the x side. I'm going to draw an arrow and write out the function for the y side. So think about those as 2 separate functions. One for the x, one for the y. You should be writing whatever in. All we have to do is take our x and y value that they give us as our input and plug it into the function. So we are going to do 3 times what?
3.
Good. And minus 1. Over here, I'm going to plug in 2 for y. Everyone okay so far? I'm just plugging in my pre-image. Okay, and then all we have to do is simplify. So what is 3 times 3? Minus 1?
8.
8. So I'm going to kind of zoom back in. There's my new x-coordinate. Okay, let's simplify the y. What is 5 times 2? 10. So my new image point is 8, 10, but I need it to say a what?
A prime.
Very good, a prime. So now that it is my image, it has to have a prime symbol. So you just take the function, plug in your pre-image. Alright, I'm going to let you guys try this next one on your own, so I'm going to pause here, and you guys can work with a partner. Okay, double check your answer with that one, and then we're moving on to... Now they gave us the what? If it's C prime, they gave us not my pre-image, they gave me the what?
Image.
They gave me the image or my output. So instead, we are going to be setting equal. So when they give me the image, and I should have written pre-image on the last one. When they give me the image, that means I'm going to set it equal. Set it equal. So it's the same concept as what we were doing, but now we have to break up the equations for an x and a y. So let's go ahead and look at number 9 here. It gives me C prime, which is my output or my image. So I'm going to take my x value that it gave me, 13. I'm going to set it equal to the equation or the function for x, which they gave me as what? What's the equation that has x?
5x plus 3.
5x plus 3. That will help me solve for my original x value. We're going to take negative 7, which is my y value, and set it equal to the function for y, which is what? 7y was my function. So do you see what I did there? I broke up the equations, broke up the functions, and set it equal to the correct number. So we should be okay solving here. I'm going to go ahead and subtract 3 from each side. I get 5x equals, what's 13 minus 3? 10, and my last step is to divide by 5. So x equals 2. That is my original or my pre-image x value. Now we just need to solve for the y. So how do I solve for y here? Divide by 7. Negative 7 divided by 7 leaves me with negative 1. So there's my pre-image point, so it needs to just be named C, no prime. So that is when we work backwards to solve for the input. Questions there? Go ahead and set up our next one if you're okay there. Okay, I'm going to keep the video going here, so please just set up this next one and we'll solve it together. So set up that last one, please. Promise we're almost done.
Are we supposed to?
We worked backwards to find the pre-image, so no problem. Good question. Okay, I'm looking at your setup, please, for this last one. So you take the value it gave you, set it equal to the correct function. Good job, Brandy. Good job, guys. So start with the number it gave you. Good, some of you are already solving, that's totally fine. We're gonna do it together. Well, that one side was, I didn't see the other side. Okay, so negative 4 should be equal to x plus 7. A positive 4 should be equal to what? 2y over 3. Very good. So let's go ahead and solve. I would subtract 7 over here. So I'm left with x. If both numbers are negative, I'm going to combine them and keep it negative. So this is going to be negative what? Negative 11. So there's my x value. Looking for my y value. So I have a 3 on the denominator. How do I cancel that 3? Multiply it. Very good. I'm going to multiply each side by 3. Those cross out. I'm left with 2y equals 12. And last step, divide by 2. So y equals 6. So my original point would be named just point D. Without a prime, right? We're looking for the pre-image there. Okay, last little part is going to be like 1 minute long and then we'll be done. Any questions with this?
No.
Yes. Questions with this? Alright, this is just in another format called the function machine. So we see we have a function, we have an input of -1. When I plug it in, -1 plus 5 leaves me with my output of 4. So just kind of like another visual way to look at that. They're just using words instead of like an x or a y or an f of x. So my input was 3. I plugged that into my function, x plus 5, and I got my output of what? 8, right? 3 plus 5 is 8. The only difference here, they gave me what? They gave me output. So instead of plugging it in, what do I have to do with that? You don't plug in output, we do what with output? Set it equal to. So here we set my function equal to 11 and solved for 6. So let's go ahead and try the first one together. We're using the same function here, so my input is what? My input is? -4. I'm going to plug it into my function, so that just tells me to add 5. -4 plus 5, or 5 minus 4 is what? +1. The 5 is a bigger number, so it stays positive. Next one is output. So I'm going to not plug in -1. What am I going to do with that -1? Set it equal to my function. What is my function?
X plus 5.
What's in my function machine? Yeah, x plus 5. And I can easily solve for x there. So I'm going to subtract 5. Here's a good example. When my signs are the same, add and keep it negative. -6. So there's my output. Okay, last one is an input. So what do I do with input? Question there? Negative, right, because they're both negative. So it's going to continue into the negatives. -1 and a -5. Oh no, sorry, yes. Because we subtracted 5 there. Okay, input we plug in, so we are doing 2.5 plus 5, which gives me 7.5 as my output. On your prep work, which I'm going to pass out in just a second, you have some tricky fractions to work with. I think these are the most difficult questions on the whole paper, number 1 and 2. So if you want to like postpone those and do what is easiest first, you guys, it is 2:47, so you have 33 minutes left until the bell rings. That is a lot of time that you can spend getting done with your prep work and not having to work for the weekend. So I'm going to pass that out now.